Arrays are one of the most important fundamental concepts to understand about programming in MATLAB. In a previous video, we looked at how we could take individual text characters and group them together to form strings. We can generalize this concept to think about grouping together data of the same type, including numbers, to form arrays. Another name for an array is a matrix. In fact, the name MATLAB comes from Matrix Laboratory. One thing that sets MATLAB apart from other programming languages is specifically how it groups together data in arrays and then how you can process things with it. This will be very convenient for us when we start to work with audio signals. First, let's have a look at how we can create some arrays working with numbers, and then we'll come back and have a look at what are some of the rules whenever we're working with arrays. Here are a few examples to demonstrate the process of creating arrays. Let's start out by working with numbers. As an example, let's say I want to create a variable with the name array1 and assign it the value of a sequence of numbers that I group together to form an array. To do this, I'm going to use the square brackets. Inside of the square brackets, I'm going to enter the numbers that I want to use. How about 2, 7, 6, and 11. When I'm done with my sequence of numbers, I close it off using the other square bracket. Now when I go to execute this command, what I've done is I've taken this entire sequence and assigned all those numbers together into a variable with the name array1. One thing to note here is that I've arranged these numbers in a horizontal fashion. That's not the only way, though, that you can create arrays. Next, let me show you how you could put them together vertically. So how about another variable called array2? This time, I'm still going to put the numbers inside of square brackets. The difference is, instead of using a comma in between the numbers, I'm going to use a semicolon. What the semicolon means is that take this number and place it on a new line. So I've got 6, I've got 11. Now when I execute this command, you can see the result is the same numbers but in a different arrangement. There are actually lots of options for how you can arrange numbers in arrays. As another example, let's look at how we could combine together both a horizontal arrangement and a vertical arrangement. So here, how about array 3? I'm going to use the square brackets again. Watch this. To start out with, I'll put 2, 7 to say, put these two numbers side by side on the same line. But then I'll use a semicolon, go down to the next line. Then I'll put 6, 11 to say, take these other two numbers and put them on the line below. Now I can use a square bracket and execute this command and now see how these numbers are arranged. Let's look at another example here where I'm using text information instead of numbers. How about array 4? This time, I'll still end up using the square brackets. Let's put in some text information. How about an H, E, L, L, and finally an O. When I'm done, I can close it off with the bracket. I can execute this command. So here you can see I've grouped together these separate parts of text into one big long string. One thing I wanted to point out with this example is I've actually removed, and I'm not using a comma in between these text strings. In fact, all I'm using is a space. This works with text, and it actually also works with numbers. I could demonstrate the same thing with my first array here. Remove the commas in between. This is a choice that you can make as a programmer. As long as you have a space between the numbers, MATLAB will interpret it to say these numbers are separate and go in different places. It's your choice to figure out which way you like, whether it's better to explicitly put in the commas to help you read your code, or if that's more complicated, you can just use spaces. One thing I want to show you though, is there's a rule when it comes to creating arrays. You should just use arrays for the same data type, so either numbers or text. Some strange things start to happen if you try and mix and match text with strings. So an error would be, let's say I'm going to create an array, or at least attempt to create an array, where I use some text. How about 2 in single quotations to say this is text information. Then also put in 4 and 6. In this case, remember, 4 is a number, 2 and 6 are text. When I go to execute this command, we actually have some strange things happening where we get the text information, but we lose the number. So you have to be careful when you have different types of data. It's much better just to think about working with numbers in their own arrays and text in their own arrays. Let's look at some other interesting things we can do. Besides just putting individual numbers into arrays, we can actually create arrays out of other arrays. So let's create one here called array 5. And I'm going to use square brackets just like I've done for all the other ones up to this point. But instead of just typing in a number, I'm going to type in a variable name. How about array 1 here? And I'll put a comma, and how about another number? Maybe -4. Watch what happens when I execute this command. Here, what happened is, in place of array 1, we've substituted in that entire sequence, and then added on to the end of it, we've concatenated another number, -4. We can also create another array out of this one. So how about array 6? This is an array, and this time I'm going to put together 2 other arrays. So here I'll use array 5, that was the one from my previous example, and then array 1. So here I'm just putting together 2 arrays to form one other one. Execute this command. Now you can see the entire sequence of numbers starting with array 5, 2, 7, 6, 11 minus 4, and then the other array, 2, 7, 6, 11. So that illustrates several different things about creating arrays. Next, let's look at some of the rules that you must follow whenever you're creating and assigning arrays. An array is created by grouping together individual pieces of data. These individual pieces of data are called the elements of an array. This is an important term to know. We can arrange the elements of an array in different ways. However, there is one rule imposed by MATLAB. The shape of an array must be rectangular. Therefore, the elements of the array are placed in columns and rows. Sometimes an array will have the exact same number of columns and rows, but it is not necessary. For an array to be rectangular, every single column in the array must have the exact same number of rows. Similarly, every single row in our array must have the same number of columns. Let's have a look at several examples of creating arrays in a rectangular shape. Here are a few examples of creating arrays. They will all be rectangular, but they're going to have different shapes and sizes. Or in other words, let's look at how we can create arrays that have different dimensions. To begin with, we're going to be working with the square brackets. This is how we can group together the elements of our array. The most simple kind of array is one that has a single element. So I'll just put in a number here for that element. It has one row and one column. This kind of array has a special name. It's called a scalar. So to help you remember the name, I'll use it for my variable name. I can execute this and see that this individual element has been assigned to this variable over here. This array that has one row and one column, you can describe its dimensions as being a 1 by 1 array. Now let's look at an array that has multiple elements. I'm going to arrange them here horizontally. Just pick some numbers to fill in for the elements and group these together. This kind of array, where we only have one row, no matter how many columns we have, this has a special name. It's called a vector, more specifically a row vector, because it has one row. So I'm going to assign it here to a variable rowVect. I can execute this and see that I've got them arranged in horizontal fashion, one row and 3 columns. So the dimensions of this array are 1 by 3. There's also something called a column vector. So I'll create this one. Instead of being horizontally, we're going to arrange the elements in a vertical fashion. Do 1, 3, and 5. So again, the semicolon means add this element on at a different new line. So here we've got 3 rows and 1 column. This is a 3 by 1 vector or 3 by 1 array. So vectors are always going to be when we just have 1 row or 1 column. Let's look at then when we've got multiple rows and multiple columns at the same time. So here's one. We're going to end up with something that has 3 rows and 3 columns. So this will be a matrix. Pick some elements here, 4, 5, and 6 across the top, the first row. Then we'll go down to the second row, the second line. Put in some other elements here, 1, 2, and 3. And our last row will have 7, 8, and 9. Then we'll put our square bracket to say this is the end of the elements that we want to group together. Now you can see how the numbers fill in this matrix right here, or this array. We still have 3 columns and 3 rows. Again, the order of it is the number of rows, number of columns, 3 by 3. So we don't have to always use a square. We could also use something that's rectangular. So how about something here where we have 2 rows and 3 columns? Put some elements in, 0, 2, and 4, and 1, 3, and 5. You can execute this. 2 rows, 3 columns. This is a 2 by 3 array, 2 by 3 matrix. The dimensions of the array are not only important just to understand how we're going to arrange the elements, but they're also important for thinking about how we're going to combine together arrays or concatenate new information onto this array. So let's look at some examples where this becomes important. So to begin with, let's think about concatenating something onto maybe an array we had before, like the column vector. So here's our column vector. It looks like this. Let's say we want to add on scalar here to the bottom. So add on a new row, but keep it in the same column. So to do concatenation, I can use the square brackets. I'm going to put in here column vector and then say go down to a new line, and add on scalar. This is an acceptable thing to do because we're maintaining the dimensions of this array. We still just have 1 column and we have 4 rows now. But something that would be an issue or an error would be if we tried to add scalar on in a new column. So here we'll do column vector. We'll try to add scalar. This is going to result in a problem. The dimensions of the matrices that are being concatenated are not consistent. What is this telling us? Well, our first array, or first vector that we started out with, it has 3 rows in 1 column. However, when we go over here and we just add scalar on, this only has 1 row. So because the dimensions do not match, it's impossible for us to concatenate it because the end result is not a rectangle. But besides just using vectors, let's look at an example where we add on, for instance, our 3 by 3 matrix to our column vector and see how that's still going to create a rectangle. So instead of scalar, let's go over here and add on matrix. This is going to be a larger array. All right, this is acceptable. Why? Because we're not changing the number of rows. We still have 3 rows. So when we add on these other new columns, all of these columns still have the same exact number of rows. So the end result is a rectangle. That's a good thing to keep in mind. So when it comes to arrays, it's very essential for a programmer to be comfortable with knowing how to create arrays, understanding the dimensions of the arrays, and then what that means when we start to add arrays together or concatenate them.